last frequency filter. So right now it's roughly at 100 hertz. So what we did to find the delta T was we shifted one cursor. Oh, it's not a cursor. We shifted. So we chose one cursor. So right now it's at cursor 2. We shifted it so that we can find the maximum voltage reading, which we found to be. Right now it's reading 2.4, but there's a broad range at which it's 2.4.
2.04.
Or 2.04. 2.04. So we found where it starts becoming 2.04, like around this point. We took note of the delta T. We moved it until it's to the other side until it stops being 2.04 again, and then let's see, right there it drops. So we took measure of the delta T. So we compared the two delta T's and we find the middle, and we end up being here somewhere, and we assigned that as our spot, as a highest peak. So we have to measure the other peak. So what we did was we changed our source to channel 1, and then we moved to the other cursor. So this is the first. This is the one that the cursor we were at in first source. Now we moved to cursor 2 to the second cursor. So we do the same process, and then that way we can find the peak. And using this method, we're able to find the delta T that we need. And since we have delta T, we have the frequency. We can find the phase shift using this equation.
There you go.
And we can change the hertz reading by just simply let's see, not there.
Oh, sorry. So then if we want to change the frequency, then all we have to do is just deal with the fine adjuster over here. So then originally we were, oops, sorry, I messed up, but we were trying to get it to 100. Oops. Yeah. And then when we want to switch it, which I believe is to 200, then we just shift it a little bit. Same thing using frontal just at fine adjuster. And we'll also flick it to one. There we go. Make it 200. Yeah, this is Amanda. Sorry, talking at the same time. Hello.
Amanda.
Okay. And then so 200 hertz right there. And then if we flick it to, let's see, 1 kilo. Hello again. Sorry. Okay, don't worry, we got it fixed. So there it is, 1 kilohertz. And so now we're going to show you how changing the frequency, actually increasing it, will basically take out the output. So go ahead. Yep, so now it's at 2 kilohertz, and now it's at 3 kilohertz, soon to be 4. And you can tell that the blue line is the input and the yellow line is the output. And so you can see that because it's a low-pass filter, it's actually causing the output's amplitude to be less. So in order to measure our amplitudes in this case, what you could do is you would push the cursor button, and then you can measure it, which, let's see here, I'm trying to do it at the same time. Cool. And so then you just set the type to be at the amplitude here, and then you can kind of use the cursors here. In this case, I'll be changing channel 1, which is the top one, as you can see. It's going up and down. And so I'll just move it to where the amplitude is at. And I'll switch it to cursor 2, and then we can also see the amplitude of that guy as well, which in this case, it'll be roughly 720 millivolts, I think. Let's see, I'm gonna increase it closer. There we go. Now I can see it a lot better. So I'm just gonna make it just barely touching the top. There we go. So now we have 720 millivolts here, and then our first cursor is showing 1.92 about, and so the change in voltage is 1.2 volts. Cool. Want to switch it to time, which Ramon also demonstrated. You can just switch the cursor setting to time, and then you can change the cursors via these buttons here, changing it from cursor 1, cursor 2, and then you can change these two lines and kind of fiddle around with it to find your delta t, which you also use again to find your phase change via this equation. Cool. Okay, awesome.